Hi everyone, good evening and welcome to our live session on how to allocate cloudlets to dedicated virtual machines. And I'm just trying to have this live after so long, just trying to connect. So let's get started quickly. Generally, if I give you a context on that, uh, how the cloudlets in the Cloudsim are allocated to the virtual machine. It's more of a process of data center broker, which basically aligns the submitted cloudlets to the virtual machine, which inherently gets hosted on certain kind of um host. Just give me one sec. Need to check one very important thing. All right, cool. So I hope the audio is clear. So somebody wrote that there is some challenge with the audio. Anyways, let me know if my audio is okay to you. Great. So let's get started with the thing. So let me just share my screen, and here we have the setup. So what I did is I basically worked out to set up the CloudSim 5.0 before starting this uh, live session. So here, if you look at, we are trying to have the CloudSim example 1.java to be executed. So by default, when I'm executing this specific um, uh, you know example, in this particular case, there is only one cloudlet which is being displayed as an output over here. So let me just show you what exactly is the code, just to give you a brief understanding on how exactly we are working out. So let me just get myself out of the picture so that you can see the whole screen. So here you can see there is a main function. So just to give you a context at how this particular example works. So Cloudsim example one is basically basically a simulation which will have one data center, and that data center has one host, and then that uh, host will be provisioning certain VM to it, which is again one, and we are only going to run one single cloudlet within the virtual machine. And if we look at the structure of this program, so we have a couple of methods over here uh, within this Cloudsim example one. So here you can see a main function, which is going to be the starting point for this simulation example. Then we have a create data center, create broker, and finally we have a print cloudlet list. So when we go further and check on the details of main function, we can see the initiation of the simulation has been done by using these set of instructions. Then a data center is created, which is named as data center 0. And then data center broker is created, which is basically responsible for taking the request of user as a cloudlet and pushing it to or provisioning it to certain virtual machine, which inherently goes to some host. And if we look at that, what sort of configuration do we have for the virtual machine? In this case, you can see the virtual machine configuration is defined in terms of MIPS. That means if I say this is 1000, that means 1000 cloudlet instructions will be executed in one clock tick time, which is generally treated as 1 second. And size is basically storage, RAM is basically your random access memory, bandwidth is in M bits, and so on, right? And that VM instance is created and that is added to the VM list. Similarly, because we have to submit the list to the broker, that is how the submit guest list has been done. Now, because 5.0 has a little bit of change in comparison to 3.0.3 version, so we have submit guest list over here. Then fifth step is basically creating a cloudlet list where you define that what sort of workload you want to simulate, and that this is what is being given over here. So you can see the ID is being given. The length of the task is 4 lakh, where your VM can only execute 1000 MIPS in one clock tick time, which is 1 second. So that means it is going to take 400 times, which is really displayed over here in your output as well. Then we have a Cloudlet instance created, and that has been submitted to the broker, and you have the guest list being added as a virtual machine ID, VM ID, which you have just recently created over here on the top. And then finally, you submit the Cloudlet list to the broker, and the simulation has been started and so on. So right now, if you look at this example, there is only one single task or Cloudlet is to be executed. Now, first thing that we should do is we should understand that how we can have a multiple set of Cloudlets to be created in this simulation. So it's very easy. So in case if you want to have more than one Cloudlet, you just need to uh, do an iteration around these set of instructions. So let's say I want to have 40 Cloudlets to be created. So what I'm going to do is I'm just going to simply write out a for loop. So let's say for int I equals to 0, semicolon I equals to uh, not equals to less than 40, because I want to have 40 Cloudlets to be created, and then I plus plus is to be done. Then I just start the uh, the particular instance over here, and that's how my Cloudlets are going to be created in a multiplicity. So right now what is going to happen is this for statement and its block is going to be executed for 40 times, and every time this iteration is going to be created, the Cloudlet will be created. The only change that you need to do over here is that you have to have the ID to be incremented by 1, because this ID is supposed to be unique. So what we do is, instead of 0, we will put I over here, which basically is a counter. So in case if you want to have a more clarity, let's say Cloudlet count can be the variable name we can give over here instead of I. So Cloudlet count, and here also, and finally the ID is equals to Cloudlet count, and this is how it is going to work for us. And finally the list is going to get populated. So just to show you that how this one single statement adding or two single changes added to this code is going to generate 40 different Cloudlets for the simulation. So I'm going to execute this program, and you can clearly see that we have the 40 set of Cloudlets created, where the ID is being started from 0 and is going towards the 39. So this is one of very important thing, and you can clearly see that this particular task, all tasks are taking the same time, and they have started at the same time and they have finished at the same time. Why this was happening over here? This is because we are utilizing we are utilizing the time shared. Let me just show you what is my virtual machine. So you can see the Cloudlet scheduler time shared is the specific scheduler for the Cloudlets we are using. So if I change this from time to space, so in this case, if I try to execute, you will find that okay, so space is required to be added in the package list. So instead of time shared, I'm also going to have a space shared. So as soon as you do it, you will find that I'm able to execute this particular program in a sense. Okay, sorry, I had to change the place. That's why I'm just pausing in between. So here, what we are trying to do is we are trying to execute. Let me just see what is the problem we have made. So, okay, so sorry, instead of Cloudlet scheduler, I have tried to change the VM scheduler. So here, this is what is required to be changed. Instead of time shared, space shared is required to be added. So as soon as we do this, you will find that we are able to execute our Cloudlets in a sequence. So as it has been submitted to the uh, data center broker, it is going to execute it in that same sequence. So first task starts at 0.01. When the simulation started, it finishes as 400, whereas the next task starts at 400 and finishes at 1200, and so on, depending upon what is the capacity that we are having for our virtual machine. So this is how you can make it work. And for every individual part, you can see there is only one virtual machine ID, that is 0, is being allocated over here. So let me do one more quick thing for you. Let me add one more virtual machine. And you can see over here the set guest ID is being set with the VM ID that has been created on the top. So let's say I do one more for statement. So for int VM count equals to 0, VM count less than 2, VM count plus plus is required to be done. And that's again what we are doing over here. And instead of VM ID equals to 0, we are going to make it VM count equals to VM ID equals to VM count. So now if I try to execute it, you will find that whenever I execute the program, okay, so we have VM list PES number. So I think we are using this PES number from the top. So here again, I'll have the copy and put it over here, right? And the VM ID that we are trying to set, I'm just going to okay, so just for an instance, I'm going to have int VM ID equals to 0. That's it. So why this error has been happening? Because the VM ID that we have just created is over here. So if I let's say, instead of making that change, I'll put VM ID equals to 0 over here, and then this VM ID is supposed to be put into this. And here, if I go for the separation, so now the errors are resolved. Let me just rerun this. Okay, so it says the host is not available right now. So primarily what is the case happening over here is that we are trying to allocate a virtual machine with the higher capacity, that is 1000 MIPS. That means we are trying to create two virtual machines over here. So just to clarify, let me take you to the create data center place. So here you can see the host MIPS capacity is only 1000. So if my host has a capacity of 1000 MIPS, how I can share it with two virtual machines which individually has 1000 capacity for the MIPS. So if I increase it to 10,000, or maybe because we have two virtual machines, 2000 capacity is required. So if I try to do this, you will see that my MIPS has been increased for the host, which is within the create data center part. So my virtual machines are hosted and the error is gone. Right? It's a small thing that we have to take care of, but yes, that can be done. Now, if you have given your attention over here at the output, you can see the virtual machine ID is what virtual machine ID is VM ID is one set to one. Now, why this happens? Because if you come over here on line number 94, we said virtual machine ID is going to be 0, and then we are changing the virtual machine ID with VM count. So uh, because the loop is going to be executed for two consecutive ways, so it starts from 0, goes till 1, and then it exits the loop. The VM ID is going to be set to 1 in this case, and that is how the all the tasks are being allocated to the VM ID, because what we are doing is we are setting the guest ID as VM ID. So if I just do a comment of this particular line, that is line number 134, where Cloudlet is set to a guest ID, that is VM ID. And if I try to execute the program again, now you can see, because we are going to have a space shared program over here, or space shared cloudlet scheduling over here, you can see the each individual cloudlet has been separately allocated to the virtual machine. So depending upon how your cloudlets are going to be executed in a sequence, that's how it is going to be working out. So you can see Cloudlet 0 and Cloudlet 1 starts at the same time. Their total execution time is 400, and next execution starts at 400. Then 2 and 3 are going to get started, and so on. So this is how the criteria is going to be working out. So here, what we understood is that we can have a multiple cloudlets which can be allocated to a dedicated virtual machine or can be allocated by default by the simulation as well. So if we try to do a math on this, you will be able to see that uh, 10 cloudlets, 20 cloudlets have been allocated to virtual machine 0, and 20 cloudlets are been allocated to virtual machine 1. So just to have a smaller inputs, let's say if I run the simulation only for the 10 cloudlets, that means 10 tasks, you will be really able to understand it, that how it has been working. So right now, because we have set the guest ID, VM ID to 1, then because of this, all the tasks have been allocated to VM ID 1. So this is a dedicated allocation, hard code allocation to a virtual machine. So maybe you want to have a prioritized virtual machine to which you want to allocate. That's how you do. Otherwise, if I comment this line, just commenting this one single instruction is going to help me uh, to facilitate the simulation engine itself to do the job of allocating the task to, or job of mapping the task to the virtual machine. So you can see the allocation of each task is equally. So 0, 0, 0 and 0. So 5 VMID equals to 0 is there, and 5 VMID, if you count 1, 2, 3, 4, and 5. So 5 tasks are been allocated, or 5 cloudlets are been allocated to VMID 0, and 5 are allocated to VMID 1. So this is how you can go and basically allocate the individual cloudlets to the dedicated uh, virtual machines, and you can remove them as well. So that's how you are basically able to work out with your various procedures and all. So I hope I am able to make the understanding about that how a cloudlet can be allocated to a virtual machine. And do let me know how did you find this live, and give me some feedback on it, so that going forward I get you the uh, dedicated topics for the live sessions as per your requirement, right? So with that said, uh, thank you very much for joining in for this live. If you have any kind of questions, queries, and so, do put it in the comment. I'll try to reply back. And if there is any specific requirement you have regarding Cloudlet, I Cloudsim, for which you have, let's say, some question which I can explain on the live stream, I'll try to bring that on for you guys. So before signing off, just a request: subscribe to my channel, have a notification bell icon set to notify you, so that I should be able to send you a quick update on whenever I'm starting my live and so. And that's it for this live. So thank you very much. Do not forget to subscribe and keep coming back to the channel. Right? Bye bye.